So myself, Rakesh Rao, Executive Editor of First Construction Council, welcoming you all for today's webinar on bridge construction. And this webinar is jointly hosted by Construction World, Infrastructure Today, and Equipment India magazines, along with First Construction Council. Hope my voice is audible to everybody.
Yes, yes.
Thank you. So before we proceed, let me brief you about how we are going to proceed ahead on these events of today. After my brief presentation, there will be a keynote address by our special guest, Lieutenant General Raju Chaudhary. And this will be followed by a panel discussion of 1 hour. Post that, we will take few questions from the audience. So I would request all the audience to type in your questions in the chat box throughout the uh, duration. And we will take these questions towards the end of the panel discussion. So with this, let me start my presentation, a short presentation on First Construction Council. Just give me a second. Yeah. Is the screen visible to everybody?
Yes, yes.
So the First Construction Council is an infrastructure think tank focusing on providing the latest updates on construction industry and is dedicated to promoting its causes and the needs. The First Construction Council is governed by a board of governors who are distinguished leaders. You can see them on screen. Mr. D.K. Sen from L&T, architect Hafiz Contractor, then Mr. Pradeep Singh, former VC and MD of IDFC, Mr. Vinayak Pai, MD and CEO of Tata Projects, Mr. Sandeep Singh, MD Tata Hitachi, Subodh Dixit, former Executive Director of Sapoji Palanji. So members of councils benefit in more than one ways. This includes industry networking opportunities, knowing consumption trends, understanding the market condition better, and access to growth opportunity. And how do members achieve all this? Through white papers and research report released by the council, and through several events and webinars, conferences, and industry ceremonies organized by FCC. On June 11th, June 11th, FCC has hosted Mumbai Redevelopment Summit, bringing together builders, developers, housing societies, government bodies, and other decision makers to discuss Mumbai's transformation through redevelopment projects. As you as you could see on the screen, it was attended by leading experts, including Mr. SVR Srinivas, CEO Dharavi Redevelopment Project, and Dr. Niranjan Hiranandani, among others. The event provided an opportunity to connect with key project leaders and discover new business revenues and limitless growth prospects. Next week on June 25th, FCC will organize the 5th Construction Technology Summit at Courtyard by Marriott in Mumbai. The event will discuss the impact of technologies such as BEAM and 3D modeling, geospatial technologies, robotics, AI and ML, etc. on the future of construction and infrastructure industry. The Construction Technology Summit presents an exclusive opportunity for 10 groundbreaking startups to showcase their ideas, technologies, and solutions that can transform the future. Then on September 3rd and 4th at Geo World Convention Center, Mumbai, First Construction Council will host the 15th Rasta Expo that promises to be a hub for innovation, collaboration, and forward-thinking solutions in the world of road construction. Rasta, which means roads and highways, sustainable technologies and advancement, is dedicated to advancing the integration of sustainable technologies, cutting-edge machinery, and smart practices in road infrastructure development. Rasta Expo will be held as part of 11th Construction Festival, a congregation of key events such as Rasta Conference, 23rd Construction World Global Awards, and 13th Equipment Awards. So on the screen, you could see the list of events that First Construction Council is going to host in 2025. So in case anybody is interested in any of the events or want to be a part of First Construction Council, do drop in an email at contact@firstconstructioncouncil.com. So coming back to the today's topic of discussion, India's vast landscape demands robust infrastructure and bridges serves as a vital links that ensures seamless connectivity across rivers, valleys, cities, and remote regions. Landmark projects such as Chenab Rail Bridge, Atal Setu in Mumbai, Sudarshan Setu have showcased engineering excellence and strategic intent under the national programs such as Bharatmala Pariyojana and National Infrastructure Pipeline. At the same time, there are many challenges. Multiple incidences of bridge collapses in the country underscores the urgency for structural integrity and real-time monitoring. So against this backdrop, today's virtual panel discussion will explore ways to build bridges that are not just stronger, but also smarter, safer, and more sustainable. Our guests for today's webinar include Mr. Dharmanand Sarangi, former DG, Road Development and Special Secretary to Ministry of Roads and Highways, Government of India. Dr. Harshvardhan Subbarao, CMD, Comstrom Consultancy. Mr. Sanjay Patil, VP and Head Bridges Business Unit, Transportation Infrastructure at L&T Construction. Mr. Sanjay Kumar Sinha, Founder and MD, Chaitanya Projects Consultancy. And Mr. Vinay Gupta, MD, Tandon Consultants Private Limited. The session will be moderated by Mr. Ashutosh Kapoor, partner KPMG in India. So before we proceed, now I would like to stop my presentation. I would now request our special guest for today, Lieutenant General Raju Chaudhary, for his keynote address. Before he starts his speech, let me share a few words about him. Lieutenant General Chaudhary is the former DG of Border Roads Organization. He has over 4 decades of illustrious service in Indian Army's corps of engineers deployed and operated in diverse terrains, commanding high-performing units, and participated in all key military operations. He has demonstrated leadership and expertise across various domains, including engineering and infrastructure development, project management, defense management, strategic planning, and instruction and training. He has a proven record of managing large-scale projects under the challenging of terrains and climatic adversities, optimizing operational efficiencies and leading diversely knit teams to achieve outstanding results. For his distinguished service, Lieutenant General was awarded the Vishisht Seva Medal and 3 commendation cards by Army Chief and Army Commanders. Lieutenant General is also the chairman of Rasta Expo Committee 2025. With this, May I request Lieutenant General to start his address?
Thank you, Mr. Rakesh. Good afternoon, Mr. Pratap Padode, Mr. Rakesh, all the experts, the panel, include Mr. Ashutosh Kapoor, Mr. D. Sarangi, Mr. Sanjay Patil, Mr. Vinay Gupta, Dr. Harshvardhan Subarao, Mr. Sanjay Kumar Sinha, ladies and gentlemen, and our esteemed guests who have connected for this webinar from different places. I feel very honored and privileged to deliver this keynote address for such a wonderful subject close to my heart. That is bridge construction in India, building the future. At the onset, I must compliment Mr. Pratap Padode, founder president of FCC, to bring together the industry, the policy and decision makers, the academia, and the innovators. Now, this is a very good uh, beginning to find optimal solutions for complex real life ground problems in bridging domain. Now, today, Indian bridge infra market is expected to observe a CAGR of approximately 6.2% within the next 7 years. A huge jump of $26 billion from 42 billion US dollars to 68 billion dollars in 7 years. And this has been possible due to the government huge push to infrastructure development through capital infra budget increase by 11.1% this year. This year, the budget for infrastructure is approximately rupees 11.11 lakh crores. That relates to approximately 133 billion US dollars. Government has also liberated the FDI rules and extended the interest-free loans to the state government for any kind of infra investment. So that is a huge kind of support to the infrastructure development. And in this, especially today, we are talking about bridge construction. This boost by the government will result into a lot of innovation being fostered and facilitate adoption of advanced bridge construction technologies. It will also enhance the connectivity and increase the transportation efficiency, the logistics in the country. Today, we are constructing the highways at a rate of approximately 45 to 50 kilometers per day. And today we stand in the world as second largest country with highways. Government has also announced Bharatmala and Sagarmala along the land and coastal borders, which will have a huge complement of bridging. Now, as mentioned by Mr. Rakesh in the beginning, there are a number of challenges. Number of bridges get collapsed within 5 years. In fact, last year during the monsoons, I still remember there were 12 bridges alone in Bihar which drowned in 15 days. And that is a shame. And the construction quality suffers in some of the places. So, to meet those challenges of time, cost, and corruption, I propose a holistic approach of 4S, that is smart, safety, sustainability, and scrupulous stand. I'll just expand this for the ease of understanding. First is smart. We must start using sensors for auditing the structural safety of the bridges. We had in BRO within 3 years had done physical structural audit of all our bridges, that is 608. So, and that we were the only construction agency in the country which had done two. We must start using digital twins. We also should rely on a lot of AI now. AI is coming in for our designing purposes, modeling, 3D modeling, and BIMs, and 3D printing. Now, 3D printing also we experimented in BRO through L&T, where L&T constructed the world's largest 3D printed building complex for BRO. But I have also gone to IIT Ahmedabad, where they had shown me the construction technique of 3D printing to make small bridges, foot bridges. It will take time for transportation bridges to use 3D printed, but then that has started and we must explore that possibility. Second comes the safety. We must design in a manner that the bridge is safe. When I used to design bridges and in my younger days and the buildings, I used to have a cushion for construction techniques and corruption techniques in this field. I'll not hesitate to make a mention that construction industry is the most corrupt industry in, not only in India, it is in the world. So I used to design my bridges through STAD and NISA and also do manual calculations and reach somewhere to cater for this kind of deficiency in our construction practices to give the final design. It should include all kind of features to minimize risk of accidents. Now, very recently, you would have also come across, they have made a bridge which turns 90-degree in Bhopal. Now, I don't understand how it happened. This is whose mistake that has to be known. But this kind of things should not be accepted. There should be regular maintenance of bridges and also clear safety protocols to be followed through dynamic traffic management and AI-based systems. Third comes the sustainability. We must start using new products for construction of bridges apart from the conventional ones what we are doing now, recycled steel, low carbon concrete, maybe CFRC, precast and prefab members, and long lifespans. And fourthly, which is very essential in today's times, that is scrupulous stand. We all are part of this menace, what troubles our bridges, the construction quality. We should follow zero tolerance for corruption. We must expose the officials within our system and beyond our system who encourage corruption and follow all the policies. Because if we don't follow all the policies, it results into cost and time overruns. In PRO, we had enforced that everyone, all contractors, firms which are working for us, they should come on check. There was a lot of resistance. Even the PSUs, the steel, PRO is supposed to be the largest buyer of steel and cement in the country as far as the government departments. There was a resistance and I pushed that if you don't come on GEM, we don't buy steel and cement. So PSUs also. And second thing what we could do is towards this end was 90% of the bills of the contractors and the firms were cleared in 9 days. That was never heard. Because you all understand, you have been in this field, that it takes 1 year, 1.5 years, and sometimes 2 years also, and people keep delaying this kind of thing. So for that, it resulted into a lot of confidence building measures. I told the contractors and the firms when I used to talk to them that you are part of the same team. You sit on the same side of the table. We are a very cohesive group which is working on the same projects. We are not different. And that resulted in a lot of cost reductions and faster construction. So this kind of things generally should not be person dictated. It should become institutionalized. We should formulate such policies that it cannot be tempered when the person goes. Today, India stands, we take pride in Ram Setu. It is the oldest known bridge made by humans, Nal and Neel. And today, very recently, it was the Chenab Bridge was inaugurated by Honorable Prime Minister, which is the highest rail bridge in the world. So we can take a lot of pride. And once we follow this 4S, and there are a number of bridges which make us proud. Atal Setu, maybe Bandra-Worli Sea Link, then Bogibeel Bridge or Bhupen Hazarika Bridge, which is the longest bridge on the river, Havra Bridge, Godavari Arth Bridge, and such like many bridges are there which make us proud, which make the community which deals with this domain very happy. But then the other end should also be of the spectrum should also be dealt very heavily. and we must not be found lacking in our morals, our principles, and our construction practices. I wish all the best to the bridging fraternity, and my best compliments to again to Mr. Ta Padode and all the experts. I finish my keynote address here. Thank you very much.
Thank you, Lieutenant General Chaudhary, for your inspiring words and enlightening thoughts. So with this, let me move on to our main agenda of today, that is the panel discussion. Before I hand over the virtual platform to our moderator, Mr. Ashutosh Kapoor, let me introduce him and the other esteemed panelists for today's discussion. Mr. Ashutosh Kapoor is a partner with KPMG in India and is part of a major projects advisory practice, an architect by training and a project management professional. Mr. Kapoor has more than 2 decades of industry and consulting experience in providing design, construction, project management, business transformation solutions to public and private clients undertaking large-scale capital projects. He has worked across regions, including US, Middle East, Asian countries, and India, with different stakeholders, including owners, developers, engineers, and contractors. Our first speaker, panelist, Mr. Sarangi. He has over 35 years of experience and has worked in various departments in needs of Ministry of Roads and Highways and is considered an expert in highway planning, designing, construction management, and maintenance and traffic congestion avoidance. As the Director General, Road Development and Special Secretary, he was responsible for policy formulation for planning, development, construction, operation, maintenance, and management of entire national highways in the country and safety of users. At present, Mr. Sarangi is the Vice President of Permanent International Association for Road Congress and Technical Advisor of Indian Roads Congress. Our next panelist is Dr. Harshvardhan Subbarao, who is the CMD of Constroma Consultancy. He is the first Indian to be elected in the nearly 100 years as the president of International Association for Bridge and Structural Engineering, Zurich. He is involved in design and design checking consultancy services for large infrastructure projects, highways, expressways, bridges, tunnels, and metros. He has been the designer of several hallmark award-winning projects. He is also the director of Institute of Asset Management India chapter and a member of Bureau of Indian Standards Subcommittee on Asset Management BIS MSD 12. Our next panelist, Mr. Sanjay Patil, currently serves as the Vice President and Head of the Bridges Business Unit at L&T's Constructions Transportation Infrastructure Independent Company. He has extensive experience in the infrastructure sector. Before taking the charge of Bridges Business Unit, he was the project director for Atal Setu project in Mumbai. Throughout his distinguished career at L&T, Mr. Patel has overseen numerous bridge construction projects. The Bridges Business Unit under him is currently managing 6 major projects, all situated in challenging terrains across major rivers with a total length of 35 kilometers. Then we have Mr. Sanjay Kumar Sinha, who is the founder and managing director of Chaitanya Project Consultancy. He has over 35 years of experience in infrastructure and consultancy sector. He looks after the company's growth, finance, and quality of work. A civil engineer with a master's in building science and construction management, he has built a strong reputation for leading with honesty, vision, and care for people. At 57, Mr. Sinha continues to focus on expanding Chaitanya projects globally, proving that Indian businesses can compete and succeed on world stage. And our last speaker, Mr. Vinay Gupta, is the managing director of London Consultants Private Limited, and he specializes in bridges, flyovers, underground and elevated metro structure. And he is also the All India Director General of Indian Institute of Bridge Engineers and past president of Indian Concrete Institute. He is an active member of various code committees of BIS and Indian Roads Congress. He is the recipient of several awards from IEI, IBC, and also the coveted SB Joshi Memorial Award 2019. So on behalf of First Construction Council, I would like to welcome you all. With this, I would request Mr. Kapoor to take over the proceedings.
Thank you, Mr. Rao. Happy to be here and a warm welcome to all of you. As we proceed from here on for the panel discussion, we will cover this panel under 3 rounds broadly. Let me introduce these rounds to you. The round 1 will be basically foundation, as you can understand. It's focusing on discussing about policy, design, guidelines, strategic reforms, which are shaping up the India's bridge future. The round 2 will be around execution excellence, an important area, of course. Talking about discussing on site practices, sustainability, like Mr. Chaudhary highlighted, material innovations and quality oversight. The round 3 will focus on using, BIM, emerging technologies like digital twins, advanced materials, predictive maintenance, all of that. So essentially focusing around smart bridges, right? So to cover these 3 rounds in an hour is going to be a stretch. We try our best, but humble request to all the participants to keep their answers very, very sharp and focused so that we can cover the ground as much as possible. So with that said, let's begin our first round. And let me go to Mr. Harshvardhan Subbarao, sir. So you've designed some of India's most iconic bridges and now lead the IBIS as well. In your view, what international design trends or innovations do you believe India must adopt very urgently to make its future bridges world-class and resilient? Sir, over to you.
Am I audible?
Yes, sir, you are.
Thank you for your kind words, Ashutosh.
Mhm.
It's been a privilege to contribute to India's bridge infrastructure and now to serve the global bridge engineering community as president of the IABSC. It is indeed wonderful to be in my position. To make India's future bridges truly world-class, a few international trends warrant urgent adoption. First, performance-based design, which focuses on how structures must behave under extreme events, which you see are increasingly happening, rather than just depending and meeting prescriptive codes, which can greatly enhance safety and durability. So performance-based design as a first. Second, digital technologies, including geoinformatics, building BIMs, use of smart sensors, digital twins, and AI-driven asset management. That is fully AI-driven asset management are transforming how we plan, construct, and maintain bridges worldwide, and we should be into that domain as well. These tools improve precision, reduce life cycle costs, increase the reduce the carbon footprint, make for greener structures, and most importantly, support predictive maintenance. So digital technologies to this goal. Third, the wider use of advanced materials. On the material side, there have been leaps and things have gone ahead quite a bit, huge leaps, like UHPC, which is ultra-high performance concrete. Normal concrete, say, has a strength of 50 MPa, whereas this can have strengths up to 200 MPa. So you save a lot, and you get stronger structures. The use of advanced carbon fiber polymers in our structures, in our repair rehabilitation, which have very low weight, completely are far greener, have lower carbon footprint, and don't add much dead weight when we repair and rehabilitate our structures. Green cements, the low carbon concretes that result out of the use of green cements. High strength steels, today in India, we're at 450 grade steel, whereas in certain countries of the world, we've gone up to 960. That's twice as strong. So there is huge improvements to be made in the steel manufacturing itself that warrant some huge change. Service life, extending corrosion-resistant steels, we lose a lot of national wealth to corrosion. So if we use weathering steels, if we use corrosion-resistant alloys into our steel manufacture, we will greatly reduce this national waste and improve the service life. And of course, the impact on the environment will be substantially reduced. These have been proven globally and ready for broader application in India now. We should get into that. There's, of course, on the construction side, the need to adopt advanced approaches like accelerated bridge construction, like replacing, say, an ROB overnight, having it on the side and sliding it in. And of course, having low weight and the whole construction processes, the cranes or the launching techniques that go with it, improvement into these paradigms. This is required. Lastly, of course, switching the whole paradigm to a life cycle asset approach, life cycle analysis and life cycle cost approach, an LCA type approach. The cost especially would embracing, say, modular prefabricated construction methods can accelerate project delivery while ensuring long-term sustainability and resilient structures. For this, if we want to encourage life cycle cost approach, the GFR of the Government of India has to change. There is a word in it which prevents the compulsory use of life cycle cost and life cycle assessment in bridge, even at the bidding stage, for example. That is the use of the word may rather than shall. If you look in the GFR, the life cycle cost is mentioned, but it is not mandated by the powerful use of the word shall. So the GFR there needs to change. India has talent and ambition. With a right push towards at least these few subtle things that I've talked about, we can set global benchmarks in bridge engineering. Believe me, we're already demonstrating that. Now it is to use these building blocks and go take that quantum leap ahead and prove to the world and be with the world that we are leaders in bridge engineering and bridge construction and bridge maintenance.
Great. No, thank you, sir. Very relevant points. So moving on to Sarangi sir. Sir, so you've been instrumental in framing quality assurance and construction guidelines during your long tenure at MOTH and very important contributory tenure as well. So in your view, sir, what critical reforms are still needed to ensure consistently high quality bridge construction happens across India, especially in the Northeast and Himalayan regions, which are tricky, troublesome areas? So your point of view, sir.
Thank you very much. In fact, for somebody, I drafted the IRC SP 112, that is the manual for quality control of highways and bridges. See, if the question of quality in bridges construction is concerned, based on a recent analysis by Central Road Research Institute, lifespan of road bridges in India is somewhere less than 40 years, although we design bridges for 100 years. That's a very, very worrisome fact, and the quality of construction is the major responsible factor for the same. To my mind, quality of construction, if it becomes not up to the desirable mark, there is laxity. It's primarily because of three reasons. Integrity issues are there, of course. But I should say more than that, there are two things. One is lack of knowledge, skill. All those persons involved in construction and its supervision, starting from contractor to the consultant to the authority or the department. So there is a very, very strong need for knowledge, skill, upgradation. And the third point is sometimes, many times, the pressure of progress overtakes quality. So to achieve more progress, we have been ignoring. And if you see the cross-section of bridge failures during construction or in the immediate aftermath of construction, you'll find there are top to bottom contractors, consultants. It is not any region specific, everywhere it is happening. So there is not, we can't ascribe it to a particular issue. So it is, we can say, prevalent throughout the country and throughout the industry. To improve it or to remove it, we have taken a lot of steps, but I must admit this has not yielded the result that it should. Primarily, to my mind, the knowledge and skill of the personnel, the ground personnel of both contractors and supervision consultants should improve, so that in terms of construction methodology, in terms of even quality control tests and acceptance of a particular material or finished work, we must be based on the standards prescribed. There is a lot of gap between what we say, what our documents say, and what is practiced in the ground. That's one point. Second point, over the years, what has happened, all the departments, whether it is NHI, MRTH, NHIDCL, State PW, or any department, some 30, 40 years back, they had a very sound bridge design cell, and during the bridge construction, involvement of the departmental engineers was very, very strong, which has disappeared over the years. We leave it to the mercy of the supervision consultants and contractors that cannot go. Each and every department must have their sound bridge design and supervision cell. In fact, NHI has made a small beginning in the recent past. In ministry, there was also a thought process to have a comprehensive bridge cell for all the executing wings of the ministry. So that's the next point. We have been blaming the L1 syndrome for long. It's truly when the bids are quoted and accepted 30 to 40% below the estimated cost put to tender, then there is serious apprehension. So something must be done. How to improve this system to take into account some quality or technical expertise parameters in the bid evaluation of the contractor, so that we can arrest this trend of low bidding. And finally, what happens in EPC contracts, we have defect liability period of 10 years, and maybe for PPP contracts, HAM contracts, 15 years, or BOT contracts, it may be maximum 20 to 25 years. That may be a very good period for the road, but for bridges, it may not be. If a bridge fails after 15 years, it can be very well construed that there were serious quality issues or design issues during the construction. So we have to develop something so that even after the DLP or the operation period is completed, still the people who are in charge of design, building the bridge should be accountable if there is something untoward happens. And unless very, very strong measures and measures that hit the people who do wrong things are taken, we cannot reverse the trend what we are seeing today.
No, great, sir. Thank you very much. I take two broad points from here. One on the set of issues, integrity, proper planning and execution, improper actually, and knowledge enhancement, lack of knowledge are typical three issues. And from your recommendation perspective, sir, you highlighted that strong supervision, bridge design capabilities to be enhanced, improve abnormally low bids, how they can be managed better. And the last part is the DLP period enhancement or increase accountability to get some mechanism in place which sort of takes into account all of these areas. So your points are well noted. So thank you very much for your contribution. Now let's move to Mr. Vinay Gupta ji now. Gupta ji, as a key contributor to the IRC codes, you've contributed to very many, especially on the segmental and precast bridges. What, in your view, are some further updates do you believe are essential to align, the bridge design standards in India with the global best practices? Could you shed some light on that, your ideas and views on it, please?
Yeah, good afternoon. First of all, let me apologize. As opposed to international trends, which anyway we are very good in copying, I would rather say that we need to worry more about how we are translating these high-profile design codes into practice at site. And I think somebody mentioned also about it. India follows a culture of chalta hai. You do anything, it should be fine, won't be a problem. And as a result, there have been umpteen number of failures. And I think Lieutenant General Rajiv Chaudhary explained, or rather he narrated, 12 accidents in Bihar. Okay, they are existing bridges, old bridges. But on the whole, when we talk of failures, there are more failures during construction than of the existing bridges. So something is wrong somewhere that requires improvement. And because of this reason, I have recently prepared certain parts of these codes which you mentioned just now, IRC SP 71, that is precast pre-tension girders bridges code, and also IRC SP 65, which is a precast segmental, as to what all is needed to ensure a good quality design, only quality design, mind you, the design aspects are there, and in the construction and the dovetailing. So this dovetailing, when we say, it is not only the contractor or the construction man who is responsible for anything that goes wrong. It is also the design consultant who produces a design drawing, everything gives it to the contractor. For example, in the morning also we were discussing in an IRC meeting, is that the contractor doesn't know what are the intermediate stage safety requirements. So these requirements have to come in an amplified manner in most of the codes. Fine, we have fantastic brain. We have done a fantastic job. We have prepared the codes and also copied good things from abroad and other codes and all that. As Dr. Harshavardhan also mentioned a few things like life cycle costing and high performance concrete and UHPC and things like that. Everything is perfect. I'll just take this one simple example of this precast segmental structure. This precast segmental structure 25 years ago was special structure. Utmost care was taken while constructing precast segmental, and therefore the number of failures were about the least. Slowly it has become run of the mill, and therefore in the hurry to construct or thinking that nothing will happen or thinking that I have a lot of experience, not to worry, sab chalta hai types, number of accidents of precast segmental have gone on increasing with the time. So we need to be very meticulous. We need to be sincere about it. We need to have certain checklists that we sign, and we need to have quality control measures for that. But yes, if we talk of the IRC perspective, which was a direct question, we have prepared a large compendium of codes, but we still need some more, which we have been discussing from time to time in these various IRC code committees. And I think Sarangi Saab is also there, and I think many of us are there in those code committees to prepare codes on various aspects. Recently, codes like the one on cable stayed bridges has been completed. The one on extra dose bridges have been completed. Now imagine for the last years and years, we were designing and constructing bridges without having a code.
Mhm.
On the other hand, for example, as Dr. Harshavardhan said, UHPC, ultra high performance concrete. There is also UHPFRC, ultra high performance fiber reinforced concrete. These things, we do not have code today. Some people are manufacturing, some people are even installing, some people are even constructing, but we don't have a code. When I ask the people who are manufacturing here, the say bridge spans and all that with these UHPFRC, I asked them, do you have a code? They said, yes, we have a code. So there's a code which says you can use UHPFRC and these are the specifications of materials. But what about a design?
Mm.
So there are a number of things where we have been just doing it without having an Indian code. And whatever we know, Indian code is like a law book.
Mm.
If you do not have this law book, if you do not have a constitution, how a lawyer can practice and therefore how a civil engineer can practice. So if a problem comes, something fails, then there is a loggerhead. So also I've deviated a bit, but sorry for that. But I just thought of what I thought was, but into Indian scenario. Thank you.
No, interesting point. I mean, you brought out two very interesting aspects of it. I mean, one, of course, we've been using materials and designing certain bridges for almost a decade or more, but with no codes on it. And the surprising part is that the data point that you shared, that most bridges are falling or failing actually during the construction time and not actually during the operations and maintenance side. Though, of course, that is the latter part gets highlighted mostly on the in the media and news, while the first part is not getting addressed at all. So that is where the needs for more stringent codes and very strong supervision certainly gets highlighted. So yeah, no, thank you, and your points are noted, well noted, sir. Thank you. Let's move on to Sanjay Patilji. Sir, from cable stayed to extra dose bridges, you've handled high risk construction environments. But in your view, what safety protocols and execution models do you believe are most effective in large-scale bridge projects? These are very tricky projects. They require very specialized skill sets, a lot of attention, very specific supervision traits, and all of that. So, what's your thoughts and views on it, sir?
Yeah, thank you. First of all, thank you very much for giving this opportunity. Yeah, my previous panel members already said about few aspects of the safety of the structures. When we talk about the construction project safety, there are three basically major safety issues come at the project site. One is the structural safety of the main bridge or structure what we build. Second is the temporary structures which enables the permanent structure. And third one is the workman and the machinery safety at the project site. I have been associated with many of the bridge and other infrastructure projects. We have a very comprehensive safety policy for the workman and temporary structures. However, for the bridge construction, the most important, as Vinay Gupta sir said just now, about many structures which have collapse has happened simply because of pre-stress and concrete issues. Yes, there is no shortcut for the any quality and safety at the project if you want to do extraordinary work at the site. There are some issues happen, but of recently many codes has been revised and implementation is happening. L&T is having its own comprehensive systems and procedures at the site, and we have recently introduced extra check while before executing the any structure for the safety of that structure and the methodology. So that is one more check we introduced at each of the project. Coming back to safety of the workman and the structures, I will tell you our safety body at the topmost is headed by number 2 person of the organization. He is the deputy CMD. He headed and each and every incidents at the project across the organization happens being discussed, debated, and the solutions being provided. Most important for any project safety is the project safety induction. Induction for the workers, induction for the machinery. It starts with the design. We have introduced all the requirement in the design phases itself. We have checked. Still, human and machinery angles remains concern simply because in Indian construction industry, workman turnaround ratio is huge. If I want to retain one workman for the project duration, it has to almost 6 to 7 workmen has to replace. Means every 3 to 4 months, one new replacement comes. And that calls for a lot of training, skill up, and that is the skill doesn't get enhanced and the safety gets backseat there. So we have a very robust induction procedure for the workers. When they come on the board, lot of technology we have been using that training models have been, we are using VR for the real type scenario we are taking, and the workmen until unless don't pass this test, then only they go for the worker. And similarly, we are checking the fitness of all the equipment which are being deployed at the site. Until unless they don't pass the test, we are not deploying. However, this is the first case. But similarly, we are of late we are using technology for the inspection of the project site, like we have cameras with AI, we are fit at the project sites and they detect the unsafe behaviors of the workers that get highlighted. All the inspectors are equipped with the digital app which escalate the matter to the respective people based on its importance to the almost sometimes it comes to my level or my boss level also it goes so that our attention gets. So nevertheless, safety we is in compromise. Everything start with safety. Our protocols and procedures are completely aligned with that. Still, the third most important, like recent, there are many natural disasters has hit in the project sites. And earlier we were not considering these, like sometimes winds, cyclones, and these were not, but temporary structures were not designed to do that. Of late, we have started everything, including that, along with the monitoring of these parameters in previously. I can give an Atal Setu. When we were doing the erection for the OSC, this one, we were per hour basis, we were monitoring this. We used to get at least 7 days advance weather reports to the accuracy of the per 15 minutes, how much wind will change. To that level, we were doing in order to avoid this. Our barges was completely fitted with the GPS system so that they will not go and hit any other area. These are the safety aspects required to take in the new infrastructure projects.
No, great. Thank you, Patilji. I think the most important takeaway from your narration certainly is that safety starts from the top. No questions about it. That's what sets the culture in the organization and at the site as well. Some other key important points that you highlighted as well: adequate training, retention of the manpower, the skilled trainer, people who are getting trained, regular fitness checkups, not only for the staff but also for the equipment. And of course, now with so much of technology prevalent, especially AI coming to rescue in a way as well, use of technology for safety monitoring. So all of this has to be like a cumulative effort of all these parameters and ideas to come together. That's what only can sort of create a safe environment. So no, thank you for your inputs on that. Thank you. Moving to Sinasa. Sinasa, in large-scale infrastructure projects, in your view, how important is it to empower the teams with independent decision making? I know it's not easy. We are all control freaks. We like to have a very strong mechanism to control our projects and the way things are happening, because we are also in a way accountable, responsible, so that the projects don't slip the timelines and they deliver the right objectives. And in that view, if you are giving independent decision-making empowerment to your people, how does this impact safety, efficiency, and overall project accountability? Can you share some thoughts on that, please?
Thank you, Mr. Astos. So, actually, when I was going through Mr. Binay Gupta ji, he said, in our industry, it has become chalta hai. I remember one instance when I was attending a meeting about 25 years before, which was being attended by Dr. T.N. Subbarao, as father of Dr. Harshvardhan. And it was going on, that time DG was Praful Kumar ji. So Dr. Subbarao said that in the entire world, nowhere a substandard quality of work is accepted. Why should we accept it in India? That led to the demolition of one span of Markanda Bridge. And that discussion was going on that day. Now, coming back to our, basically that I wanted to just mention, because we were talking a lot of things about the quality. So that was the time when he was not ready to accept any substandard works, whatever we learned from him. Now, when it comes to the giving empowerment to the teams, actually, this should be given, but with some restricted, certain restrictions. Of course, so when we empower the team, of course, they take independent decisions, they maintain the timelines, a lot of things we are controlling from the head office, the communications between the head office and the site team there is always a time gap or the delay, and which leads to the delaying of the projects. But again, what I said, that it should be the empowerment of the field team should be there, but with certain restrictions. Now, a strict protocol has to be followed, has to be prepared by the head office, and those protocols are to be followed by the site teams very strictly. Because if I just wanted to mention, but on this, whatever the designs we are doing in our head office, whatever the international practices are there, so that is very easy. That is very easy to transfer this technology in our offices. Are we really able to transfer this to our field? Because the manpower who is there in the field, do we have any training procedure? Because, okay, we have designed, we have shifted from working stress to limit stress. Now all designs are very much optimized. Is our field team is really equipped to understand that? Are they able to maintain the quality? Are they really trained to execute that? Actually, we find there is a huge gap in the manpower. If we remember an incident about last year, Israel required about 1 lakh people from our country, as skilled workers. People went there also. They had a very good certificates. Some people were fitter, machine, this plumbers, electricians. They went there. Majority of them had to come back because actually they were not having any practical knowledge. Do we have any such kind of institutions or such kind of training centers in India? So we design. Okay, design is good. All codes are there. We are preparing it in the ministry, or we are prepared. We have a lot of IRC codes and IS codes. So designs, there is no flaw in the design. Because it is undergoing through a lot of scrutinies through every individuals, through the design consultants, through the independent engineers, and department also is very much particular about the design issues. But when the moment it goes to the field, it fails in many of the cases, not all. Second thing is, when we give the complete autonomy to the field team, generally what happens that in order to optimize their profit, sometime they compromise with the quality and the machineries also. We have seen in the bridge constructions, many of the field teams, they are using, even for the pile foundations, they are using TMR. Now TMR is such a thing. So instead of this hydraulic rigs, if we are using TMR, the bottom 1 or 2 meter, we are hardly able to flush those mucks. Now, if we are casting 100 piles or 1000 piles, even if one fails, the entire structure will fail. And those chances are very high. So, as our Colonel Saab was mentioning, Colonel Rajiv Chaudhary was mentioning, there were 12 bridges in Bihar which has failed in last year itself. So, if we go minutely, so you will find in few of them, the piles were casted by the TMR. So that led to these disasters. And in other projects also, we have to be very strict in using those kind of machineries which are not prescribed in our books, in our data books. So there has to be a restricted autonomy to the field. And one more thing what I have found, the safety team has been already appointed by our client in all the project, whether it is a railway or whether it is a highway. Generally, the recommendations of safety teams are ignored, and it has led to disaster in the bridges and highway projects also. Highway, generally, we are not able to visualize those disasters unless there are heavy rains or there are heavy rain cuts we find, but in the bridges very easily it can be visible. So generally, or when it comes into the operation, we find a lot of accidents on the highways. So in majority of the projects, the safety teams which goes to the site, generally it is being ignored by the site teams. So that's why I said they should be empowered, they should be given responsibility with the restrictions. The head office team of the contractor also should be equally involved in their constructions, in their, at least particularly in maintaining the quality standards.
Understood. Understood. So I summarize your thoughts into 4 bullet points, Mr. Sinha. Empowerment with guardrails and strong accountability. That's the first point I took away. The second one was independent supervision. Third, adequate training. And the fourth one is most important, of course, stringent quality compliance. Unless you have focus on these 4 areas, giving empowerment just to your teams on ground may lead to disasters, which may be very, very detrimental to the public and the end user. Thank you. So with this, now let's move to the round 2 of our conversation. And this round focuses on site practices, sustainability, material innovation, quality oversight, etc. Some part of it we've already touched in the foundation part of it, but this will be more focused and evolved. So with that, coming back to you, Vinay Gupta ji. So, and this is a very interesting question, actually. So despite speedy construction techniques like precast and pre-stressing, where does the speed gets diluted? What comes in the way of the speed?
Yes, quite an interesting question. That on one side we say we are trying to construct very fast and we still go back. We move 2 steps forward, go back 4 steps behind. Well, of course, when I said this word, 2 steps forward and 4 behind, is purely because of failures during construction. And when a failure takes place, it takes months and months to come to a finality report. There is a lot of formalities and huge amount of time is spent or lost. But that is one of the things which we all know. But otherwise, I feel, because from my own experiences, from my own examples of even BOT projects, normal precast segmental projects, speedy projects, and everything, what hampers is our status today that we are living in a fusion of future world and Stone Age. You may ask me, what is this fusion? Future world is that, yes, we have learned some very good techniques. We copy also things very well from abroad, and we have used them here and we are using them here. But that is limited to half of the structure, which you see above. What about the structure below? We do not even know what is below the ground. The maximum unaccountable time, unpredictable time is taken in constructing the foundations. And only then you can construct piers, and only then you have control of on your time, unless you make some more mistake and something falls down or something fails. So a very good example here is that in this one elevated expressway project of 10 kilometers in Bangalore, which is from Silk Board Junction to Electronic City, the Silicon Valley of India, we can say. It was that the subsurface investigations could not be done. The geotechnical investigations could not be done at a place where the piers were supposed to be. They were done elsewhere. And being a rocky profile, there were lots and lots of variations. And the worst example, I'll give you some project in some flyovers of MSRDC at that time in 1995, 1997 in Mumbai, wherein within one pile cap, when you have 4 or 6 or 8 piles, there is to be a height difference in the bottom of the pile, foundation level of the pile, to the tune of 3, 4, 5, 6 meters. You have two piles with a distance of only some 2.5 D, that means 2.5 meters or 3 meters. And you see a huge difference because the rocky strata has this tendency, it has its nature, it varies quite a lot. So what happened in this particular project, this Bangalore I'm talking about, the Silkboard Junction project, is that the contractors, being a beauty project, were always in a hurry. So they kept on constructing. They constructed, all the piles, pile caps, also reached piers. But a routine load test of pile has to be done. All of us are aware, which is about 2% of pile sample has to be tested for routine load test. Presuming that nothing will go wrong, they kept on constructing they constructed all of them and leaving only those few where test had to be carried out. Now that means every 10th, I think, if I remember correctly, every 10th pier, they left the pile cap because the vertical load test had to be carried out. And I think Mr. Sinha and most of you will understand very well that some frequency of sample is tested of the piles, vertical load. It so happened that wherever they tested, the capacity of the pile came to as low as 60-65%. Now this is what has been constructed also is unsafe. Leave aside the new one that is yet to be done or only piling is done and you can do something. So the solution that came about was those where the pile cap was not completed, only piles were there and they were tested. Piles were doubled up from 4 to 8 and things like that, or 6 to 8 or whatever. That was still easier. But the ones which are our other 90% or say 60-70%, say 9 out of 10, a group of 10 piers, 9 of them, their pile cap was constructed, pier was constructed. There the scheme to strengthen, first of all to add 2 piles and 2 piles, 4 piles, then to strengthen, thicken the pile cap, extend the pile cap using all kinds of post-installed rebar anchors for which at that time there was not in a code. Now we have prepared a code which is just about to be finalized and published. Using that, they were strengthened. Now this time, imagine, for 3 kilometers out of 10 kilometers was a huge amount of time, maybe 6 months extra. So we, we are trying to go very fast, but we are forgetting. Many times you see that uncharted utility details are not available. And they suddenly occur when you excavate or suddenly occur when you bore your pile. Lots of these things, I think we have to disciplinize ourselves. Going abroad, I've seen that people have a fantastic information bank of all those things which are not seen above. But in India, we neither want to know nor we have any will to know. We just want to try our luck. So that's my take on it.
No, great. So I take away 3 points from your point of view that you just shared. To me, in layman terms, it comes out that focus more on the foundation piers, the areas which are not visible, than actually worrying too much about the girders on the top and the cables and all of that, because that is still manageable because that's in open, so you will not have any interferences. Sorry. But where you will get compromised is essentially on the subsoil area, specifically on the lower strata, if you don't have the studies available and so on and so forth. And the very important point that you actually said, and applicable actually across the country, is that there is no mapping of the utilities which are running, right? So in the countries like US and all of that, you call Julie, and they will come and do a complete scan and give you everything up front, so you know where you're hitting, where you're excavating, and not cutting the supply line for an hospital, for example, right? Over here there will be any surprises for that matter. So that of course is there, and I think the incremental point that gets added on essentially is adequate risk management, which is basically to ensure that proactively we are actually thinking through all these problems basis the experience that we all carry, rather than just going in the field and experiencing it every day and calling it out that today some issue happened, so by the way I could not do this. But there can be a much better programmed way of dealing with this situation. So no, great, thank you. Moving on to Subbarao sir. Sir, as someone involved in forensic investigations, I'm sure you've done a lot as well, and global bridge failure databases, so on and so forth, that you have access to and contributed as well. What are some of the most common causes of safety lapses that you have observed during the bridge construction? And how do you think the Indian engineering fraternity and the contractors also at large can actually learn from these episodes and proactively mitigate them? So, important, very valid question for you, sir.
Thank you for that question. I think that's a very valid question. But just to add to what Vinay earlier said, we are having a code on geophysical methods of investigation, which very rarely we find that these types of investigation are undertaken. They should be undertaken. That will ameliorate the risk involved with, mitigate the risk involved with unknown things below the ground. So this is something that has to be adopted. It is a little expensive, but if we combine it with geotechnical methods, like boreholes, and sometimes with simple cone penetration test, replacing boreholes, and cone penetration test can be done very quickly. We save time, we save huge amounts of money. So these radical changes have to happen, and there is a need for contractors and geotechnical persons to change the way they project this. So that is a crying need, combining geophysical and geotechnical methods of investigation, adopting newer technologies like CPT, and advanced things that are now available to replace plate load tests are hardly used elsewhere in the world. Plate load tests to be replaced by cone penetration tests, and these kind of things to replace bore logs also, which are very time consuming and so on. So these are definite issues to handle the pressure of time frame also. Coming to the question you asked me, having studied so many bridge failures and being involved with this global data failure base and being a forensic engineering person on IBC's committees and so on, there are certain patterns that's seen globally, which apply to India as well. The most common of these failure causes, and this is only during construction. I'm not talking about in the other cycle phase of concept or design or poor investigations or any of those, only actually during the construction. First is the inadequate temporary design. The temporary works are inadequately designed. It's like staging, scaffolding, form works, and the manner we take risks with those and the repeat use and not checking those temporary works under repeated use conditions. Those all are definitely common causes, the design aspect as well as repeated use without checking. Then poor quality control and inspection during critical stages and the lack of oversight. So critical stages and inspections have to be done by properly trained and persons, capable of doing such work, not by someone who is just delegated or leaves or is hardly trained for 4 weeks and so on. So lack of clarity in construction sequences, the very clear step A, step B, step B sequencing and construction sequencing, and it should be in keeping with what has been assumed in the analysis and not deviated from that. So lack of clarity in construction sequences and adherence to strong method statements, adherence to the method statements. Then lack of knowledge and insufficient training of site personnel already bought out, and retention of trained manpower. Losing trained manpower immediately sacrifices safety. Then deviation from approved drawing or specifications without a proper review. That means inadequate review of approved drawings and specifications. Poor communication between the various stakeholders. Sometimes what happens is a design approved is not what is followed, a previous version is followed, and that leads to a compromise on safety of the structure itself at a site. So these kind of safety lapses during construction are very common. And there is this chalta hai attitude, which everyone alluded to. Actually, in safety and risk engineering, it is called normalization of deviance. There is a word for it. It is called normalization of deviance, what we call chalta hai. It is the fact that we keep doing something, we push something, nothing happens, it doesn't fail. We say, oh, then we try it again, it still doesn't fail. We put 10 tons instead of the capacity of that train, only 6 tons. Okay, 10 tons a day. Okay, next time we would put another 10 tons, nothing happened. Third time, the last straw that broke the camel back, it fails. So what is this? It's the acceptance at every stage of a normalization of deviance and this chalta attitude. Nothing happened, so let's go ahead, overlook any safety protocol, go beyond problem. So these are issues which we need to deal with. In India, where projects are under very high time and cost pressures, these risks can become over-amplified, as has already been stated. Safety takes a backseat under the pressure of execution. So to mitigate them, we must institutionalize a few key practices. How to? First is a proper risk approach and risk log to be at site. Now, risk logs you will never find on any construction site of any quality. That means the risk in terms of event and risk in terms of the events that are planned and so on you add risk and you create a risk log to each of the events of construction, be it equipment, be it execution, to each activity. You are assigning a risk, and that risk is having a separate risk log. You never find a risk log at most of our sites. Then mandatory independent review of erection schemes and temporary works. This is rarely done. Treat them as important as permanent works. There shall be no compromise. They are designed for the loads that are almost like permanent loads. We must give the same importance to temporary work design and the erection scheme and processes. Okay. Now, strict adherence to inspection and approval protocols. You cannot use something just because I will give the approval tomorrow, so the person executes it at site. And then that approval finds that something is lacking in giving approval, there's a withheld. And, the approval is not got, but something has happened at site. And what needs to be approved actually not what has been executed. So these deviations are very important. So strict adherence to inspection and approval protocols. Then the use of digital tools for real-time monitoring and documentation. It can be starting with CCTV cameras, pattern recognition, machine learning, all built into such activities. It can be issues of actually how to monitor and document and use of, we'll come to BIM and so on. Then regular safety audits and capacity building programs for field engineers and contractors. Today, we are not having sufficient people to do the kind of volume of execution that we want. There is a complete dearth of trained manpower at every range, foreman, plumber, fitter, carpenter. You take any level of, we are having a huge a lack of such trained manpower. So bridge construction, I would say, is non-negotiable. Safety in bridge construction is non-negotiable. You cannot negotiate safety. It's a public asset, and you cannot negotiate safety. A culture of accountability, a technical rigor, and proactive risk management is essential to prevent these sort of tragedies that we've been seeing unfolding. So these are some of the issues and some simple approaches to mitigate them.
Great. Yeah. No, great. All valid inputs. I'll just summarize with some key points that I heard from you. Challenges during construction: inadequate temporary works design and execution, poor quality control and supervision, lack of clarity of construction sequencing, adherence to method statements is missing, retention of trained staff is not there, training of staff is not there. Inadequate review of design changes and poor communication of design changes leads to a lot of issues on ground. And some simple methods that you suggested in terms of mitigation includes risk logs, independent reviews of design and temporary works, adherence to approval protocols, digital tools for monitoring, safety audits, and last but not the least, train. All right, great. Thank you, sir. Thanks for your time on this subject. Moving to Patil ji, Sanjay ji, you've led projects across India's most demanding river crossings. This is a substantive topic here, and urban zones as well. What are the key engineering strategies and innovations that enable successful bridge construction on such challenging terrains? Can you share some of your experience? I know we are running out of time, so a brief, quick response from you will be highly appreciated, sir.
Yeah, it's very difficult to tell in 2-3 sentences of this question. But I just want to tell, making unknown to known is the most important factor at the start of the project. Any project, whatever the unknowns, you make it known. Like Gupta ji said about the soil investigation. I can give an example at MTHL project. Almost every pile we have made a GTI and made the known, unknown, all strata, and we geared that. Strategy of my all bridges is to come out of the foundation. It's the most difficult portion of the any structure. We have to focus on the foundation, come out of the structures, come out above the water, above the ground, and then we can parallelly work on the methods. in bridge construction today, the scope is increasing, timelines are squeezing. Every client want all fancy type of the bridge pylons and everything. However, because of timelines are squeezing, it's a more important to how we adapt. There is no single activity which you can say is a critical activity. Each and every activity is critical. If you don't have a plan A, a plan B, we will not able to complete the projects on time. And that is what we did at MTHL. We were having a plan A. When it was not working, we done the plan B planning, implemented, and we succeeded to adhere the timelines.
Great.
But nowadays, if you across this is the sea in the urban areas. But if I give example of Brahmaputra rivers, there we are building 2 bridges. It's a very, very difficult river. It's having completely, we can't implement the same strategy what we implemented in the urban areas. We don't know this year in this particular foundation will be in water or in the land. That type of scouring is happening in the Brahmaputra. So each and every year the execution strategy changes. And if we are not equipped to adopt that strategy, we will always be chasing the timelines. So our mantra is that only we have to attack on all the fronts, make plan A, plan B, and basically the strategy will be as a custom made for the project. If we are building one bridge at Ganga over also, there the river pattern is completely different. So completely every season we are making a new plan and making a new strategy for that season, make a remobilization, demobilization again, and execute as per the plan. That is what we are doing at L&T, sir.
Great, sir. No, thank you for your insights. I think very valid, and I know it's a very difficult answer to summarize in 2 minutes. It's a session in itself, and we'll still be short on that. But I appreciate you sharing your thoughts on this. Now we are frankly quite out of time. So what I'll do is that I will pick out one question from our round 3, right, which is basically focusing on smart bridges, technologies, monitoring, materials of the future, on that as a subject. I'll ask one question, and that will be open to all the panelists. Please, I'll start from one place, and then I will request one of you to just pick up the baton from where the first person leaves, and please add on to your to the thought process on that, and that's how we will culminate this conversation and then open it up to our audience to ask questions. So the question that I wish to ask all of you is that in this world now, with the technology moving so fast, and impacting business in every sphere, right? Tools like BIM, drones, digital twins have gained a lot of traction. So in your view, how prepared is the industry to adopt these technologies in the bridge construction space, and how successful we have been in adopting these as well? So first part, how successful we have been. Do you think that there is merit in adopting them? And what are the challenges and what can be done to overcome this? So a little improvisation on the questions, but very keen to hear the views from all of you panelists, please.
Shall I go first?
Please,
Shall I go first? Ashutosh, you have an order?
Yes, yeah, sure, please.
So, I mean, there is an absolute need. There's no question. Global tenders for large projects are always called on the basis of a BIM model. Okay, something like New York Metro is fully having a digital BIM. Something like our Nagpur Metro, Pune Metro is having a digital twin. Okay, so there is no question that this is here to stay. Tender documents globally require them to be mandated, right? Are mandated. So I would say the integration of all these technologies you allude to, digital twin, building information management or bridge information management, 3D modeling, drones in asset management, and maintenance of those assets are critical, and India must proactively embrace them. We don't have a choice. Now, the point really is where we see, the how to do it. what is preventing us from adopting, how to do it. We need a sort of a roadmap. I have a detailed roadmap which I will share with your printing side of the magazine. But for the moment in this discussion, I'll summarize. To mainstream these technologies for bridge projects in India, the roadmap could be policy and standard framework, develop national guidelines and standards for BIM, digital twin, and drone-based inspection, ensuring consistency across agencies and projects. He has one method and PWD has another method, and this cannot work. Okay, so the bridge is an asset and it has to be looked at from the same lens. It can be not looked at different lens through different lens by different agencies and setting different standards of inspection, tools, resolution, all those, the specs, all that has to come down to a policy and standard framework. Now, pilot projects begin with pilot implementation on selected bridges, both new and existing. So we need demonstration projects, which we don't have, to demonstrate value in terms of improved monitoring, maintenance, and life cycle planning. Okay, so this is a pilot projects to be chosen. Then digital by default, mandate BIM and digital modeling for all new bridge projects above a certain size or which have strategic importance. As several countries have already done this. As I told you, even in tender stage, it is a mandated requirement, right? So we are doing it in India, a few projects, but not all. That means the entire workflow, design, drawing, everything is fully digital. There is no paperwork. And at site, and everything is with AR, VR to imagine and XR, all integrated into the digital workflow of the full project. Okay, not only the drawings or this or the BIM, it's a full digital twin concept that we need to look at, right? Then capacity building. So see, how many of us simple civil engineers, design engineers and others have even donned a VR set, have donned an AR set? No, I would say not even, 10% of the people I know don't even know what it looks like. Okay, so we need demonstration situations here. Government has to take a huge step to set up centers where experience centers can be developed, and capacity building to train engineers, contractors, and consultants in digital workflows, interpreting such data interpretation, and emerging technologies through structured programs. Here, the government has to take the lead. There's no point asking consultants, contractors, and others. It needs a government policy shift completely to leapfrog this lack in our system, right? So the other is, platform integration. You develop centralized interoperable platforms where data from BIM models, drones, and sensors on structures can feed into the digital twin model in real time and help in decision making, intervention, what is to be done, it's a digital twin on which you can experiment, including safety, including shutdowns, including traffic accidents. It could be, so the digital twin actually is the avatar on which we can do so many what ifs. Okay, so that platform integration, including the inspection platform, whether it be drone used or whether it be satellite based or whatever technologies for inspection, all that should get integrated into the full digital twin BIM model. Okay, so also that model helps you update your own analytical structural model as well, updating of your structural model also to understand whether your parameters that you've taken are correct, because it's being monitored and that monitoring data comes fed back. So public-private collaboration, engage startups and tech companies to co-develop solutions tailored for Indian conditions, right? So we need we may be different, but these have to be cost-effective, scalable, and rugged. If you expect people to adopt them, they have to be cost-effective. They can't be, so expensive that it goes beyond pocket to understand or get into. So the challenge lies in reaching out to simple structural engineers like me, to reaching out to contractors who are, doing 500 crores, 1,000 crores type turnover on the threshold, say, to reaching out to people who supply materials, and to people who are specializing in this area of machine learning, artificial intelligence, and so on, and bringing together a collective platform. Otherwise, it is never going to happen. It's not one man's show or one man's domain. It's multifarious and multi-integrated. And to get the interoperability, we need this public-private collaboration. Okay. So by following this roadmap, I think, India can move from our traditional maintenance practice to a predictive, that gives you that ability, predictive ability, and proactive, intelligent asset management. This will obviously have benefits. The benefits of that are safer, longer lasting, and more cost-effective bridge infrastructure. That is obvious. So there's no choice. It's the roadmap to do it. And I had put some thought into developing a strategic roadmap, 5-year plan, as it were. I love these 5-year concepts. So I have something which I will share with you for each of the stakeholders, government, asset owners, contractors, consultants, academia, all, okay, for all of them. And it has a typical foundation, adoption, integration, optimization, innovation type of breakdown. And what are the steps to be taken under that? I'll share that for you for print. So digital transformation in bridge infrastructure is not a technical challenge alone. I don't think that is the issue alone, but a strategic one. India has to realize that it is a strategic requirement, and collaboration among stakeholders, as I said, is critical to building resilient, efficient, and intelligent bridges, smart and intelligent bridges for the future. So I'll share that roadmap separately with you, Ashutosh.
Great. No, thank you. Thank you, sir. Gupta ji, any views?
Yes, I thought I'll share something on the grassroots level, not a big policy level. You see, first of all, let us all know and understand that in our designs of structures, say for that matter, box structure, where we know that the inside of the box structure is not visible to the naked eyes. You have to travel inside the box, and therefore there's a requirement of certain vertical height clearance inside the box, which means the depth of the box girder has to be so much that a person can, with some difficulty, move inside and inspect. So it's about 1.5 to 1.8 meter. That's the requirement. Fine. There has to be a cutout. There has to be a space for the person to move through. All that is fine. But yet, people go there only when there's a failure. So we need something like drone. Now these drones can not only do the visual inspection for you, but they also, there are tools which drones can fix it on the surfaces and carry out simple things like remount hammer test, depth of carbonation test, so on and so forth. As a matter of fact, this Millau viaduct in France, which is about, I think, 3 kilometers long or something, has 2.5 kilometers long, has all been inspected during construction and post-construction using drones continuously. And we can do that, and we know the technology, there's nothing, nothing difficult in it. We can have, when we can take photography for a marriage, why not all this? So it's a very useful tool in today's world when people are not willing to come out of their comfort zone and go inside the box and inspect unless they see a failure. Then everybody is alarmed.
Correct.
So that is one thing. Secondly, just going one level down, in the code that I prepared for this segmental girder bridges, segmental box girder bridges and all that, I've written a line very recently, I did I think last year or something, that at every place of activity, there should be a CCTV capturing everything. Because when there's a failure and you go and find out, nobody will tell you what happened.
What happened,
So you can't fix responsibility. That's one thing, which is of course secondary, if I may say so. But it is to know why it happened. You can know only from a recording. In one of the failures, some resident nearby had a CCTV camera, and that gave us a complete feel as to how the collapse took place. It was very incidental. So we have said in the book that, look, everywhere you have to have this kind of CCTV cameras in casting yard as well as at the site and so on. So that's all I wanted to just inform everybody.
No, great. Thank you. Thank you, sir. Patilji, any views?
Yeah. We are in the very important part of our construction is the technology uses like beam, digital twins or drones. At MTHL 2018 onwards only we started each and every drawing in a 3D, and then we graduated to scheduling, costing and execution also in that. And right now in our organization, each and every project is mandated to have a 3D drawings. We have a separate cell of beam which controls all across, and this has helped immensely for execution of the project. Because you can visualize the project on day one, the issues and the lot many we can overcome during the project, and before we can take action, anything happening, any activity, before that we come to know that we rework awards. As far as drones, they are a fantastic tool. What Gupta ji said or what Harshadan sir said, all these being used at L&T, I will say. Drones not only used for the photography, but for the survey purpose. We use LiDAR for that. Continuous monitoring happen, work happen, and no need to feed the further data for the some equipment if using the drones. Continuously data gets fed to the execution people. This is what. Most important in a drones were the high risk activities like work at height or painting and inaccessible areas. We are it is in experimental stage, but I am very sure in a certain time it will come in the painting of the bridges, which is one difficult activity at the bottom. I am very sure we will do with the drones.
Understood.
And this presently it is being used for the certain purpose, but certainly some human work will be replaced by the drones. We are in that this one. At our every project site, our all drawings are digitized. If everywhere the QR codes are there, if you scan the QR codes, you will able to access the drawing which is required for that project from that your mobile itself. We use all digital tools to identify like segment casting. At MTHL, almost 7,000 segment we casted. In each segment, we have been fixed a chip. If you go and scan that chip, you will get all the details of that particular segment, including drawing, the casting date, everything, all details you will be able to access. So technology is playing very, very important role, and we are taking advantage of that. And certainly we have to go miles together now. There are some challenges to implement the technology because skill gap is huge there. In the terms of availability of network, you say hardware, huge issues are there. But yes, it is going to be helpful to the complete the project before time. The technology is only solution for the future.
Sounds good. Thank you for your inputs. Very, very valuable. Sarangi Saab, very quickly, some views, and then Sinha Saab to wrap it up, please.
As regards technology, it is already coming into the projects, but in different scale by different people. To have a uniform yardstick, I have every doubt because the government cannot make it mandatory. What happens if I give you a small example in a NH project in Maharashtra? What happened? The contractor first went for spine and wing type of superstructure. There was under construction failure and straight came to iGadder. So unless and until it is not only the cost, but it should be also the capacity of the contractor or consultant to use a particular technology. There are instances where technology used, but then unless you retrieve the data from it, you don't use it subsequently, it's meaningless. Those kind of experiences are also there. But all said done, we have to transform ourselves definitely for these emerging technologies. But it is better we do it slowly, and it is done by the people who have the right capacity and aptitude to do so.
Understood. Important, sir. Sinha Saab, any last views?
So our other speakers also have already given, they have enlightened about the uses of the beam. Only I would like to add that it must be made in the days to come. It will be very popular because it visualizes the complete project before the start of the construction.
Mm.
It reduces the design errors and the clashes.
Mm.
So we must encourage our industry to use the technologies as far as possible.
Mm.
Yeah.
Great, sir. No, thank you. That is very, very helpful. So very valuable inputs that came from everybody. One sentence that I take away from this entire dialogue on this very important topic is digital by default. That's very simplistically put and summarizes this entire topic in the conversation. So with that said, thank you very much to each one of you panelists who have contributed immensely to all these important discussion points that we tabled today. And I hand it over to Mr. Rao. Please, you can take it forward from here. Open up, if you time permitting, to the forum to ask any questions they have to the esteemed panelists, please. Mr. Rao, over to you.
Thank you, Mr. Kapoor. I could just see one question in the chat box from Mr. Gaurav Pandey. It's related to BIM. So he is asking, I will just repeat. Is a longer pre-construction time for BIM model greater maturity up to good for construction up to LOD 350 not mandate in longer window period between contract sign off versus contract started? Anybody wants to take that question? It's related to BIM.
Yeah, longer pre.
Gaurav Pandeyji, would you like to clarify that question?
Construction.
Unmute yourself. Okay.
I think what the person means, Mr. Pandey, if I understand correctly, and Mr. Pandey, you can correct me if I'm wrong, is that what you're saying to prepare the drawings and designs on BIM, it takes longer time. So that means from award of the contract till issuance of the construction drawings, it takes a longer time, longer window period between the contract. It is when will we get a true blue India BIM software like Tally and Finacle was homegrown in the well. I think what you're questioning in the second one is that why not an Indian software or something as opposed to the standard BIM or Revit or whatever people have been talking about. But yes, it does take a longer time in the beginning. But what is most important is saving of the overall time, which means once you have digitized it, it has taken more time to digitize. It has gone into BIM 350, LOD 350, or whatever level we define. Thereafter, to make changes, to understand things, to correct things if there are, to avoid any clashes of utilities, reinforcement, pre-stressing, anchorages, etc. Those are the advantages which otherwise you get surprises during the construction which nobody wants, and they take more time. So your time gets compensated like that. That's my understanding of this.
Okay. I think we are already overshot by 20 minutes. So this is a time to conclude today's session. Thank you, first of all the panelists for an excellent thought-provoking deliberation. And with this, we would like to come to an end to today's panel discussion. I would like to thank all the panelists and Lieutenant General Rajiv Chaudhary ji for sharing their valuable insights on such an important topic. It was a pleasure having you all for today's event. We would like to thank all the participants who joined us for today's event. We would look forward to your participation in our next virtual meeting of First Construction Council on tunneling technology. That will be on July 17th. And I would also request all our participants to do visit us and do participate in our 15th Rasta Expo. That's going to happen on 3rd and 4th of September in Geo World Center, Convention Center, Mumbai. So thank you once again to all. And till then, thank you and bye. Take care.
Thank you.
Thank you. Thank you all.
Bye-bye.
Thank you. Thank you all. Good day.
Thank you.
Thank you, sir.
Thank you all.